Welcome, dear Middle 3 students. This is the first lesson in science this year. In the first unit, we'll continue speaking about a topic that we have previously studied, which is motion. Okay, of course, in Middle 2, we have studied two types of motion. Do you remember them? We have studied together the oscillatory motion and the wave motion. Okay, in this year, we'll be concerned with the third type of motion, and actually it is the simplest type of motion, which is the motion in straight line or the motion in one direction. First of all, let's remember together, what is the definition of motion? What is the definition of motion? Okay, as you see, this train moved from one place to another during a specific time, right? The train moved from this place to this place during a specific time. This is motion. So we can say that motion is the change of object's location as time passes according to the location of another object. Again, it is the change of object's location as time passes according to the location of another object. We can understand easily the first part of the definition, which is that the change of object's location as time passes. But why we add this sentence, according to the location of another object? What is the benefit from this sentence? This is because sometimes you feel that you are moving, but actually you are not. How? For example, if you are in a train, and this train didn't start motion yet, but the opposite train start to move, you will feel that you are moving forward. Okay? Of course, it's just a feeling due to a type of motion called relative motion. We will study it later. But now, how can you prove to yourself that you are still at rest? The only thing you can do is by looking from the window at any fixed object, like a tree, a light post, okay? And by comparing your position with the position of this fixed object, you will be sure that you are still at rest. This is the reason for adding this sentence, according to the location of another object, okay? To be sure that you are actually in a state of motion. The motion could be straight, like this, curved, this is the second type, like this, or number 3, both of them straight and curved in the same time, like this motion. Okay, so we have 3 types of motion, straight, curved, or both of them. Of course, the simplest type of motion is the motion in straight line, the motion in one direction, like this. Okay, this is the motion in straight line. It is the simplest type of motion, and it is our topic this year. We'll concentrate on this type of motion. But there is a problem. Motion, the concept, we can't measure it. What can we do? How can I measure motion? I want a tool to measure this motion. I want something expresses motion and can be measured. But motion is a concept, we can't measure it. To make the motion able to be measured, we need something else expresses motion. We need something else expresses motion. Okay? What is the thing? It is speed. Okay? So speed expresses motion. If a car covers a distance of 10 meters during 10 seconds, for example, like this one, this car covers a distance of 10 meters. This distance is 10 meters, and the car covered it during 2 seconds. Okay, what is the distance covered by the car during only 1 second? Concentrate. The car covered a distance of 10 meters during 2 seconds. So during 1 second, the car covers 5 meters. Okay? This means that the speed of the car is 5 meters every second, or we can say it 5 meters per second. This is the speed. This is the speed of the car. So, give a definition of the speed, we can say that it is the distance covered through unit time. The unit time here is 1 second. So again, this is a very important definition. Speed, it is the distance covered through unit time. Okay, this is the second definition. The first definition was motion. Okay. Actually, now it's very important to stop the video for a couple of minutes and try to remember these two definitions, motion and speed. And of course, I recommend to do this by writing. Now, let's see the factors affect the speed. Let's see the factors affect the speed. I have two balls here, the yellow one and the blue one. Okay, both of them moved. Which one is faster and why? Of course, it is the yellow ball. But why you decide that the yellow ball is the faster one? Why? Let's see it again. What happened? Actually, yes, of course, the yellow ball is faster because it covered the same distance in shorter period of time. In shorter period of time. So, the first factor that affects speed is time. And they are the relation between speed and time. They are dot proportional. What can we say? When the time decreases, when the time is shorter, the speed what? The speed increases. The yellow ball was faster, its speed is higher because it covered the same distance in shorter period of time. So when the time decreases, the speed increases. This relation is called inverse relationship, or we can say that they are inversely proportional. As the time decreases, the speed increases. Okay? Let's see the second factor. What happened this time and which ball is faster? In this case, the yellow ball, again, it is the faster one. Why? Because in this case, the ball is faster as it covered a longer distance in the same time. A longer distance in the same time. So that the second factor that affects speed is distance. And from this example, we see that as the distance increase, the speed increase. So they are directly proportional. They increase together and decrease together. When the distance increase, the speed increase. Or we can say, as the object cover longer distance, the speed increase. Okay? So, after all we have said, can you conclude what are the necessary factors for the description of speed? We have only two factors, time and distance. So the speed, again, it is the distance moved or the distance covered through a unit time. When the time decreases, the speed increases. They are inversely proportional. And at the distance increase, the speed decreases. They are directly proportional. From this, we can conclude a rule for speed. Speed have a symbol V, which means velocity. Okay? For now, we can say speed and velocity are the same thing. There is a slight difference between speed and velocity. We'll discuss it later. Okay? So, speed equal distance divided by time. Again, speed equal distance divided by time. As the distance increase, the speed increase. And as the time decrease, the speed increase. Okay, so the relation between speed and time is inversely proportional. The speed, they are opposite. The relation between the speed and distance is directly proportional. What about the measuring units of speed? As we said, speed equals distance over time. Distance is measured by meter or kilometer, while time is measured by second or hour, right? So the speed can be measured by meter per second or kilometer per hour. Okay, so you have to put the compatible units together, the small units together or the large units together. What if in the problem the time is given by minutes? We do not ever use minute in our problems, so you have to convert it either to second or to hour. Okay, let's see a small problem. Let's see a sample problem. Calculate the speed of a swimmer who swims 120 meters in 60 seconds. Okay, first of all, you have to read the problem carefully. Then you have to detect the given. Calculate the speed of a swimmer who swims 120 meters. So the distance D equal 120 meters in 60 seconds. So the time equal 60 seconds. What is the rule that you will use to calculate the speed? Speed equal distance over time equal 120 over 60 equal to what? The unit is very important. The unit of speed, 2 meter per second. If you didn't write the unit, you will lose marks. Okay, a second problem. Runner runs with a speed of 8 meter per second. Find the distance covered by the runner in 10 seconds. Again, read the problem carefully. Detect the given, detect the rule, then answer. You can stop the video now for a couple of minutes and try to solve this problem with your own. Okay? So the given are speed equal 8 meter per second. Distance is unknown. Time equal 10 seconds. What is the rule? You can use this triangle. Speed equal distance over time. So distance equal speed times time. Okay? Speed equal 8 times time equal 10. So the distance equal 80. 80 what? This is distance. And the speed by meter per second and the time by seconds. So the distance will be in meter. Okay? This is enough for now. Let's take a look for our booklet. This is our booklet for this year. We have finished the first part, which is speaking about motion. This is the definition. We have studied together now. This is the definition of speed and the rule and the units. Okay, and this is the first problem that we have solved together and the second one. Okay. After studying this part carefully, please open your Edimodo account. You will find this assignment. Okay, this is assignment number 1. Just when you open the file, you can answer it directly, then submit the file to me, and I will review it and give you marks and comments. You can answer in the same sheet, but I prefer to write the answer in a different color, like red, for example. For this one, I'll solve it with you. It is the distance moved through unit time. What is it? Distance covered through unit time. It is, of course, you have to send your assignments before the due date, which will be after tomorrow. Thank you and see you next time. Thank you.